we want to look back at our chain rule. So if we look back at our chain rule, where we've got the inside function g of x, my outside function is f of x. When we do the chain rule, it is the derivative of the outer function multiplied by the derivative of the inner function. Or we can say it is fu, so fu prime, u prime. Just makes me laugh. That's why I put that one in there. Okay, so and then of course when we integrate, we see fu plus c. So the whole point about doing the integration with U substitution is making it easier. Like when we were asked to do stuff like this, when we were asked to do x plus 3 root x minus 4 is equal to 0, we learned in pre-calc 1 that it's so much easier to learn U substitution, and you would have said let u equal the square root of x, so u squared is equal to x. Do you remember that from pre-calc 1? So that we can treat this as a quadratic. We then said this is u squared plus 3u minus 4 is equal to 0, and it made it life easier to factor. Do you remember that slightly, a little bit? So that's the whole thought process behind U substitution. Now with U substitution, the first couple of tries is going to not be really good. I'm just going to let you know. You're going to choose the best place for u because you want to think of this as u prime. Now, the first couple of tries at this, a couple of runs at this, it's not going to be pretty initially, and that's okay. If you remember when you started to learn trig and you had to do the identities, those were not okay to begin with, but with practice they were. And that's kind of like with U substitution. Your first attempt at U substitution may not be pretty, but it's going to be practice that gets you there. So what we typically want to do is choose the one that you think would make a derivative of the other one. So we want to choose one that gives you the derivative for the other one. So we want to say we think u is this, and so that we have a u prime would equal this. And what we're looking for when we do U substitution is I am looking for the easiest replacement. My goal is to always have something that looks like this. My goal is to have some kind of u du, or 1 over u du, or the square root of u du. These are the kind of things that I look for when I do U substitution, is I want to have some nice u du. Now realizing, of course, that if I have limits here, limits of integration, the upper and lower, I do need to do that replacement like we did on Friday. So let's just start out with one of these, and then I'm going to do one, you all are going to do the other one. Which one would you like me to do? B. Of course you do. So as I look at B, to me, when I see this, I think, oh, if I did the derivative of what's underneath the square root, I'm going to get the other one. So what I think I have is I think I'm going to have this to be u. And the reason I think that one is u is because this looks like u prime. That's what it looks like. So I'm going to confirm that. If that's u, then du would equal to 3, so 6x plus 1 dx. Does that make sense? So I have this replacement then. This becomes u, so it is the square root of u. And then this replacement here gets replaced with du, because I have a 6x plus 1 dx as the derivative of what I think u is. So then the 6x plus 1 dx gets replaced with du. So what this becomes is the integral of the square root of u du. So I'm going to stop, and I want to know what kind of questions do you have for me? Yes?
So the dx that's on the very back, that's not attached to any specific term. We can move it wherever we need.
Yes. Yes. So the question is, that dx, it's not really attached to any specific factor, and the answer is no. You can attach it to whatever one you need to attach it to. Notice I attached it to the 6x plus 1 because when I said u was equal to 3x squared plus x, when I did the derivative of that, then I needed to have the dx attached to that derivative. What other kind of questions do you have for me? Yes?
So the dx is attached to whatever the d prime is.
Yes. So whatever you decide u is, when you do the derivative of that, then ideally that is where the dx is attached to.
And all that turns into du and everything.
Yes. So we have a replacement for each piece. Ideally, yes. Now you see this is a much easier derivative because I can just rewrite this as the derivative of u to the 1/2 du. No. Now I do the antiderivative, so I add 1 to the exponent. Remember, this is not really there, so I add 1 to the exponent there, which means I'm also dividing by 1/2 plus 1, because that should have been there. So this is going to be equal to, well, 1/2 plus 1 is 3/2. The reciprocal of that is 2/3. So 2/3 u raised to the 3/2 plus c. Now all I have to do is replace what u was. What was u? U was at 3x plus x raised to the 3/2 plus c, and that's my final answer. Much easier to do an antiderivative on than what we started out with. What kind of questions do you have for me before I have you do the other one? Okay, so go ahead and do this one. All right, so let's take a look at this example. Let me erase this part right here. What did you all decide u to be? Okay, so let u equal x squared plus 1. So du would equal what? 2x dx. Don't forget that dx so that you see that there is a replacement. So this part here, not that part, this part gets replaced with du, and this part on the inside gets replaced with u. So this becomes the integral from, well, there isn't any units there, so u to the 4th du. How was that? What is the antiderivative of this? Equals 1/5 u to the 5th plus c. And one last step. What is my last step? I'll replace the u back in. So this is going to be replaced with x squared plus 1 raised to the 5th, 1/5 of that, plus c. How was that? Okay, cool.
Wait, will you go back up?
Absolutely. What kind of questions do you have for me on this one? So antiderivatives are not that bad, especially after you learn your derivatives. Which is why you keep taking that test over and over again until you get a good grade, because you need it for this. What other kind of questions do you have for me? Okay. Go ahead and do C and attempt D, please. Okay, so on C, what did you all choose for u to be? Let u equals x squared? Yeah? du is equal to 2x dx. Do I see 2x there? Nope, I just see what? X. So because I see only x, I have to divide this side by 2 and this side by 2. So I have 1/2 du is equal to x dx. Now do I have a replacement? Yep. So here's my replacement. This gets replaced with du, 1/2 of du. This gets replaced with u. So this is equal to 1/2 e to the u du. So what is the antiderivative of e to the u? E to the u all day long plus c. What's my last step? Put the u back in. And that's it. What kind of questions do you have for me? Yes?
Why would we want to do it?
It would have worked out the same thing. It would have worked out to the same thing. So the question is, how come I didn't use u? Let u equal e to the x squared. It would have worked out to the same answer. So then you would have had du is equal to 2x e to the x squared. You still would have had to divide by 2. So 1/2 du is equal to x e to the x squared. So then your integration would have been 1/2 u du. Yeah? 1/2 u du? 1/2 u du? Yes, no? Yes, no? No, yes. Do we know what we're doing today?
Yes.
Fine.
Not to replace u with e to the x squared.
So then we have the integration of this gives you 1/2, and then it'll be u raised to the 1 plus 1, right? Over 2 plus c. So I get 1/4 e raised to the 2x squared plus c. Is there a problem with that?
Well, it's not the answer you got before.
There is a problem with that. What is the problem with this, besides the fact it's not the same answer?
It's 1/4.
If I take the derivative of this here, do I get the same thing as I got here? No. So you want to use, when you see e, you always let u be the exponent on e. What about this one? What does this one look like? 1 over something. What does that look like? 1 over something.
Looks like an identity for the trig identity.
1 over something. Looks like the natural log, right? Doesn't that look like the natural log?
Yeah.
So we let u equal 10x minus 3. Du is equal to 10 dx. 1 over 10 du is equal to dx. So then this gets replaced with 1 over 10 du. This gets replaced with u. So this is equal to the integration of 1 over u times 1/10 du, which is the same thing as 1 over 10, 1 over u du. What is this equal to? What is this equal to? When I see 1 over u, what is the antiderivative for 1 over u? The natural log. So this is equal to 1 over 10, the natural log of the absolute value of u plus c. Why do we have to do the absolute value? Because it can't be negative. I can't take natural logs of negative numbers. So this is going to be equal to 1/10, the natural log of the absolute value of 10x minus 3 plus c. How are we doing? How are we doing? What kind of questions do you have on me for this one? Okay. Look at that stuff. Fun never ends. Please do E, F, and G. So on E, what do we let U equal? So du is equal to what? D theta. So we have a replacement for cosine theta d theta, that's du. We have a replacement for this, which is u to the 10th. So our integration is equal to u to the 10th du. What is the antiderivative on this?
And u to the 9th du plus c.
Add 1 power and divide by that. So 1 over 11 u to the 11th plus c. It happens to all of us. So I have to replace u back, so it is equal to 1 over 11, the sine of 11 theta plus c. How was that? It was okay. It was okay. Okay, what about F?
You go back to that.
Oh, yeah. So I'll stop. What kind of questions do you have for me on this one?
It's like it's easier than it should have been.
U substitution is supposed to make your life easy. It is absolutely supposed to make your life easy. Yeah, if you know integration, if you know how to do derivatives, integration will be easier. If you're shaky on your derivatives, then integration is going to be a little more difficult.
So du just disappears the cosine on that? Or is that because that's what you get when you take?
So I let u equal this is pretty much a given, that if you see sine and cosine together like this, because we know the derivative of sine and cosine are each other, one has a negative when you do the cosine, then u is always going to be the one that's got the power on it, but not the power itself. It's just going to be u is equal to sine theta in this case. Now if it would have been cosine to the 10th sine theta, then u would have been the cosine. Yes?
So essentially we're treating the du as a variable to another term without any numbers.
The du?
But yeah, we call du as a term without any numbers, so we're kind of moving around where we want.
Well, it's not really a term, it's a respect to. So whenever you take a derivatives and you're doing it with respect to something, and I'm doing it with respect to u. So normally I would have had this, right? If u would have been like y, if I would have had y is equal to the sine theta, then I would have had dy and d theta is equal to the cosine of theta, right? So if I split this up, then I would have had dy is equal to the cosine theta d theta. But I'm not doing it with respect to y, I'm doing it with respect to u. So if you want to think of it this way, if I go back and say, okay, let's make this to u. So with respect to u, so du, and that's why du replaces the cosine theta d theta, because it's respect to. Yes?
So at the beginning of chapter 3, when we were learning derivatives, we had dx over dt or dx over dy.
Yeah.
dy over dx. Did it start with just that expression, or did it start as like du equals like cosine theta d theta, and it just moved it over before we?
So when we were doing, so the question is, when we were first learning derivatives, say we had y is equal to x squared plus 1, right? When we were doing the derivative, we also called it y prime. Well, y prime is equal to dy dx. It's the derivative of y with respect to x. So whenever we were doing the derivative and we replace it with y prime, it is the derivative of y with respect to x. That's why we don't do y prime or u prime here. Because if I do u prime here, then I'm doing it with respect to whatever my variable is. And so I don't have a replacement for that d theta or the dx or the d whatever it is. So it is in your best interest to write it as du and not u prime. Does that answer your question?
Yeah.
Okay. All right, how are we doing now? All right, so let erase this. How about this shenanigans on F? So how do we do this one?
Well, we want to do the denominator since it's right.
Let's do the denominator. So when we do the denominator, what do we get?
1,
We let u equal,
x minus 2.
so du is equal to dx. So we have a replacement for this, and we have a replacement for this. We have a replacement for the other one as well. What we do is if we said u is equal to x minus 2, then u plus 2 must equal x. So I have a replacement for this as well. So this is equal to u plus 2 divided by u du. Now I'm going to put u underneath each one of these. If I put u underneath each one of these, I'm going to get 1 plus 2 divided by u du. Dallas, you got like, what is she on today? It's not even cold medicine. It's not even cold medicine because it's a sinus infection, and cold medicine doesn't help me at all.
So we don't divide the derivative with respect to u by u.
So now I can do the derivative, or the antiderivative, yeah? What's the antiderivative of what?
X.
Yep. So this is going to equal u plus 2, the natural log of the absolute value of u, plus c. I'm going to stop for a minute. I'm going to ask, what kind of questions do you have for me? Yes.
No, that, I already answered the question.
Yes.
So whenever we take the antiderivative of a fraction, it is the natural log of that number?
If it's 1 over u, yeah. 2 is just a multiplier. So it's 1 over u. Whenever you see 1 over u, it is always the natural log of the absolute value of u.
And you just pull that multiplier with the prime?
Yeah, the multiplier just comes out front. Yes.
As long as we keep everything in terms of maybe we can solve like we did for the x alone for like any term that we have.
So, am I solving for u though? No. So what was u equal to?
X minus 2.
So this is equal to x minus 2 plus 2, the natural log of the absolute value of x minus 2, plus c. There's my final answer. How was that? Okay, cool. What about this one?
Replace the highest power term.
So you want u to be which part?
Y plus 1.
Yep. So let u equal y plus 1. Let u equal y plus 1. Trust me. You're going to repeat like we just did here. You're going to repeat pretty much what I just did. So give it a go, doing the same kind of thing as I just did, where I let u equal y plus 1. And see how far you get, and then we'll come together in a minute and go over it. So if we let u equal y plus 1, then dy, or du is equal to dy. So I have a replacement for this. This is du. This part becomes u. And then because I have y squared up here, I need to solve for y in terms of u. So then y squared is going to be equal to u minus 1, the quantity squared. So let's multiply this baby out because I have divided by u to the 4th. When I multiply this out, I'm going to get u squared minus 2u plus 1. So I replace that y squared with u squared minus 2u plus 1. And so this is going to be equal to the integration of u squared minus 2u plus 1 over u to the fourth du. Now I'm going to do u to the fourth underneath each one of those terms. And so if I put u to the fourth under each one of those terms, I'm going to get 1 over u squared minus 2 over u cubed plus 1 over u to the fourth du. Now I'm just going to write those with negative exponents to make it easier to do the integration. So this is equal to u raised to the negative 2 minus 2u raised to the negative 3 plus u raised to the negative 4 du. I'm going to stop. I'm going to ask you, what kind of questions do you have for me? What kind of questions do you have for me?
That's up to this point?
Yeah, up to this point. Up to this point. What kind of questions do you have for me up to this point?
Why did we raise it to the negative exponent instead of doing the natural log of it?
Because none of them are 1 over u by itself. So the question is, how come none of these are natural logs? And that's because none of these are 1 over u raised to the power of 1. So if I see here, any place in there, before I do the integration, if I see 1 over u raised to the 1 power, so it's just strictly 1 over u, then it is definitely the natural log. But because these are all have powers higher than just 1 in the denominator, so I'm going to raise them up to their negative exponents.
Makes sense.
Good question. Yes?
Why are we allowed to divide everything by the denominator?
Good question. So that goes back to, I'm just going to come over here to do this. If I would have had a plus b over c, I can write this as a plus b over c. So what I'm doing is I'm reversing it each time. As long as I have a single factor in the denominator, not two terms, I'm allowed to put the denominator underneath each one of my terms in the numerator. Yep. Yes?
Even if you had here, would you be able to put that expression underneath it?
Yeah, so the other question is, what happens if I would have had something that looks like this? I would have had x squared plus 3 over x minus 1 plus x plus 4 over x minus 1. And then, yes, I can absolutely, if I need to, but that x minus 1 needs to go underneath each one of those terms.
And then you'd be the same.
Yeah, but that's going to be ugly and messy, so
Yeah.
yeah. So what our goal is to have a single factor with no terms, just a single factor in the denominator, so we can use that rule backwards. Okay, what other kind of questions do you have for me before we finish this up? Okay, let's do the answer. So I'm going to add 1 here, right? And then I divide by this, so negative 2 plus 1. So this is going to be negative 1 u to the negative 1. Yeah? And then I'm going to add 1 here, and then I'm going to divide by that, so negative 3 plus 1. So negative 3 plus 1 is negative 2, and then negative 2 over 2, so that gives me just plus u to the negative 2. And then I'm going to do the next one, so plus 1 here, and then divide by that, so negative 4 plus 1. So minus 3u to the negative 3. Oh, negative, sorry, 1/3. 1/3 minus 1/3 u to the negative 3 plus c. Yes?
Are we only allowed to do that natural log conversion when we're doing the implemented?
So the only time I need to worry about the natural log is when I start out in the integration part as 1 over u, where u is to a power of 1. So now I just go back and replace. What was u again? So this is equal to negative 1, and then it's u, what was it, y plus 1 raised to the negative 1 plus y plus 1 raised to the negative 2 minus 1/3 y plus 1 raised to the negative 3 plus c. And there it is in all of its glory.